Well, welcome everybody to today's webinar, Securing Enterprise Spinnaker, Advanced Strategies for Supply Chain Security and Compliance. My name is Mark Levy. I will host today's webinar. I focus on product marketing here at OpsMx. Before we begin, a few housekeeping items. Today's session is about 30 minutes long. We're recording the session. We'll send the recording and the slides to everybody. And if you have any questions, please enter them in the chat and we'll answer as many as we can as time allots. Before we begin, I'd like to launch a poll just to see where everybody's at. It helps us put context into today's discussion and also for developing content in the future. So please take a moment to do the poll, please. And while you're filling out the poll, for those who are not yet familiar with OpsMx, OpsMx is changing the way software is delivered by prioritizing security first. We offer solutions that seamlessly integrate with your existing CI/CD platform, enhancing security and compliance. We also provide a complete end-to-end CI/CD solution as well. For those who prefer open source solutions, we enhance the functionality of Spinnaker and Argo. Our open CD architecture and automated security protocols are designed to work well within those ecosystems. Leading companies, including Google and Apple, have chosen OpsMx for their software delivery needs. They rely on us for our expertise in secure software delivery, enabling them to ship better software faster. Check us out at opsmx.com. Okay, please fill out the poll if you can. I'm going to end it now, and thank you for your time. So, if you move on, before Gopi takes over, I'd like to just sort of set the stage because really the impact of software supply chain threats are as digital infrastructures like CI/CD platforms become really more integrated into business operations. The cyber threats and the attack surfaces and vectors within the software supply chain expand. And this leads to putting both public and private sectors at risk. In fact, by 2025, Gartner predicts software supply chain attacks will have targeted 45% of the companies. And there are other issues as well. There's the legal environment is escalating, exemplified by the SEC's charges against the CISO of SolarWinds, which really signals this new era of heightened accountability. And then on top of that, you have this evolving compliance landscape. Compliance mandates like the latest White House executive order on supply chain security point out that both the federal government and the private sector need to collaborate to enhance cybersecurity, emphasizing innovation and vigilance and alignment. So there are many things that are impacting and providing threats to the software supply chain. And so to help guide us through these comprehensive issues and implications for industry, I'd like to welcome OpsMx CTO and cybersecurity specialist, Gopinath Rebala. Good morning, Gopi.
Good morning, Mark. Greetings, everyone. Thank you for taking the time to joining us. And as Mark mentioned, at OpsMx, we are making security first in delivering software at speed and scale. So when we work with our customers, we have worked over the last few years with large number of customers, both Fortune 100 and small customers. So for all of them, what we see is that the security and compliance is hard. There are many reasons for that, particularly the manual effort that is involved in getting that audit and compliance continuously monitored at an organization, even after achieving a certain compliance. So as we implemented our delivery solutions at these customers, we found some of the core issues, fundamental issues that are making it harder for the security and compliance. even for the organizations that have implemented uh, the security controls as a primary goal, we work with one of the fintech companies that has actually had the data uh, exposed. They spend about 2.5 years just focusing on the security and making sure they are secure. For them, the issue has become that the security checks that they're doing for their application delivery are siloed. They have a static code analysis that is being done at the developer side and the operations. They have the rules for the infrastructure that they have set up on which the application is being deployed. They did not have this context end to end on what is critical for their applications in terms of resolving their security issues. So the data is siloed. They don't have the context in looking at what is important, slowing their deliveries down, and making it harder for onboarding developers or new employees. The, the other one that we've seen is common, even for the smaller companies, is this manual approvals. When you're focused on security, you go through a security team is usually pretty small. In larger companies, we see 1:100, 1:500 kind of a ratio with the developers to security team. Then if you have to do the manual approvals, either you slow down your delivery a lot or deliver non-compliant software. And the other problem is this changing regulatory landscape. As we know, we have seen that increase in the supply chain attacks has caused the NIST to come up with the guidelines for the software supply chain delivery. And even we've seen that the FedRAMP regulations has a new revision that includes the software supply chain requirements. And all of these now have to be incorporated if you're following these security guidelines into your delivery process. So changing that, as you know, is a lot harder in these organizations with the small security teams and having to educate a large group of developers without the proper automation and ability to share the information. So that's one part of it. And the second part is how do you incorporate these checks in the delivery process so you have the ability to inform the developers at the time where the problem is happening. So typically what happens is at the time of the deployment, they find that the container is not compliant with the enterprise policies. It has root escalation privilege enabled in the container. So it goes all the way back to the developers and the cycle time becomes large. And what typically happens in these environments is that they take exceptions for these and then just go deploy, saying that we will be fixing it later. But the time managing how those are fixed, can they be fixed in time? All that becomes very difficult. So typically during the audit time, they find these are non-compliant software. The second part of it is securing the delivery systems themselves, right? Because of the increase in supply chain attacks, you have to ensure that the build systems, delivery systems like Spinnaker must be fully conformant to your security practices. So they must have this ability to have privileged access to only certain users, but have the visibility of their applications across the entire chain. And you need to be able to have attributability to it. And the policies that needs to be incorporated as part of your delivery to be able to deliver it faster. So these are significant gaps today, which we work with a large number of our customers to fill. And there's still some additional things that needs to be done on top. So those are some of the gaps that we will discuss today and how they're filling them. So if you look at fundamentally, working with these customers, what we found is there is a need for this DevSecOps control plane. Essentially, even in organizations which is fully automated delivery pipelines, there is a dev test cycle that's generally separate from the production deployment cycle. In between, you have integration test cycles. So each of these are doing certain checks and approvals, as well as their security analysis at different parts. And now, there is a need here for having this context end to end to be able to do continuous automated risk and automated approvals so you can increase the speed of the delivery with security and compliance requirements, and provide this audit whenever is required for any of these standards requirements. So this additional requirements are something that we will talk about in the next few slides. But first of all, we talked about two things. One is for the supply chain, you need to be able to secure the delivery process itself, delivery systems, and then the delivery process. So we'll talk about what the Spinnaker as a delivery system, what is it needed, what are the gaps today, and how we are working with our customers to fill in those. Spinnaker OSS today has some number of vulnerabilities in the binary images that are being built. There are quite a few dependent open source systems that it's using, like the Spring framework or Java, slightly older versions, and all of those need to be upgraded. And that's something that we have done based on the secure UBA 8 images and upgraded all of these libraries as part of the Spinnaker. So we have Spinnaker images that are FIPS compliant, that can work with highly regulated environments with very low security vulnerabilities, no critical vulnerabilities. These are something that we will give out to the open source, but it usually takes a slightly longer cycle for getting through the open source. But that's one of the pieces that we had to do. And the second one is enabling the secrets management. So every organization has a slightly different environment. Some of them use Google Secrets, some of them use AWS Secrets Manager or HashiCorp Vault. So not only that we need to support these secrets with the Spinnaker deployments, with the GitOps type of configuration, so we have a full track of the audit of changes of the configuration to the Spinnaker, but also how these secrets are retrieved and used. That you need to make sure that none of these secrets are in any unencrypted form, either in the configurations or in the pods themselves. And so all of that needs to be done. But this same kind of secrets management support needs to be extended to the applications that are deploying. If you don't have this support for the applications, then you have two different parallel processes. One process where you first apply your secrets and then you apply the applications. Typically, that creates a bunch of issues, because if you want to update a secret and then rolling restart your application, then you have to run two different processes. And the first process of applying the secrets doesn't go through Spinnaker. So, which is why it's important to have that integrated in Spinnaker, and that's kind of what we have done. The next one that's critical is providing the security guardrails. These can be as simple as saying that there needs to be Sarbanes-Oxley compliance. The one who's triggering the pipeline needs to be different than the one that's actually approving the deployment to the production. It's a simple policy like that. Or you may have a blackout windows that you want to specify. Or you may have a policy that says the binary that is built must be built on a specific type of build machine, and vulnerability checks for this binary must not include any critical. So these are the kind of policies you want to be able to include in your delivery pipeline and centrally managed, right? Because the developers should not be responsible for creating these policies and automating them, but you want to be able to automate it centrally in a form that can be shared with the developers. So here is the open policy agent-based policy management that we have created that integrates with the plugins of Spinnaker with the orchestrator Orca and the cloud driver. So you can specify these policies at runtime. We can also have specified policies for the configuration of the pipelines. If you require a certain type of testing, or if you require canary analysis for going to production, you can specify that, and the pipelines would enforce those requirements at the time of the configuration of the pipelines. And the last one for security, of course, is this operational continuity. You need to have the backup and recovery mechanisms. You need to have continuous monitoring, comprehensive, not reactive, but a proactive monitoring to know what your capacity is when the system is going to be unstable, and react to it to have 4 nines of availability. So even with that, there are still some gaps that you would see based on the customers that we have worked with. Because even with Spinnaker, when you're delivering with complete automation, dev cycle different from test cycles to the production cycles is fairly common in most organizations. So in that case, the results from the static code analysis or dynamic analysis or the deployment time, infrastructure analysis are all independent systems. So if there is a problem that occurs in the application, in the production, tracking them down to which code change or where the problem originated from becomes an issue. One of the organizations that we worked with, they actually had to raise a ticket saying that we have a vulnerability in this software module. Who is responsible for it? And then the dev team that is responsible for that module responds, and then they work with them. So this context is completely missing in most of the organizations. I would say 99% of the organizations. And the process compliance is specifying these policies externally. Most of the organizations today have code that they built themselves. Right? These are custom code that gets built either as a Jenkins pipelines or GitLab pipeline structures or scripting. So that makes it very difficult to make any of these changes that they may need in the process. And so that's another place that Spinnaker helps a lot, but you still need to be able to specify these policies centrally. And that's another place that we see a big gap in. And the continuous monitoring for the vulnerabilities, even after you deploy to production, it is possible that there is a vulnerability that's discovered new in some of the libraries. Now, how do you know if any of the systems that you are running in production have that vulnerability? And if there are, where are they? So these are some of the things that are still gaps even after automating with Spinnaker. So to address this issue, we have come up with a DevSecOps control plane. Essentially, it's a data lake with large number of integrations pre-built to known systems. So we have a pretty close integration with Spinnaker, Argo CD, and some of these security scanning tools like SonarQube, Aqua Trivi, and Sneak. And all of these systems then can easily provide the data to the central control plane, and we run synthesis on it. And so since we understand the structure of the data with the data lake, there is a virtual data structure that can be exposed on which we apply the policies. You can specify these OPA Rego policies in the Git, share with the developers, and these can be pre-arranged to apply on the specific type of application with the subset of these policies. So by using this structure, we can achieve the issues on the application context and the traceability from end to end, and providing immediate feedback at the time the problem occurs. So we look at the product and how it looks. With this architecture, what are the features that we are providing as in conjunction with Spinnaker, right? With automation. So you can think of Spinnaker as the continuous delivery automation, but this one has the layer that's providing the application context for security and compliance. So the first thing that we provide is with the integrating with Spinnaker, we can pull in the entire application context. We can also interrogate the cloud systems to identify what are the applications running. So one of the problems that we see most often with the security people complain is they don't even know if an application is running in an environment to even verify whether that is compliant or not. So the discovery is one of the key things, and we provide different discovery mechanisms to identify what are the applications. Once you have this application context, we have the context of the delivery. We have integrations to GitHub, integrations to different security tools, and understand the stages of the Spinnaker. We can now synthesize the risk posture of each of these applications along with the environment it's running in. As you can see, for this specific application, we identified 3 different environments. These are based on the tags. The users can come in and modify these tags as well. So now you know this application is running in these 3 environments, and each of these environments, this is a security posture. You may have different versions of these applications running in each of these environments because it's a continuous delivery process. There is a developer process where you have in your versions that they're testing and they're ready to promote to staging, and then staging to production. And so you can see what exact versions are running, at what time they've been deployed, what is their current status of vulnerabilities. The other issue that we do well here is this secure bill of materials. And so each of these components could be composed of large amount of open source software. So we know that usually there are 70 to 80% of open source software in most of the commercial software that's being released. So generating this bill of materials and comparing this bill of materials between the systems makes it very easy to know what the differences in your security posture is, right? So the other thing that we help with is this, providing the contextual view. Let's say you found an issue in production and you want to see how it got there, or what are the systems that are being affected, and what is it that you need to focus on to fix immediately. So we provide a graph view of end-to-end for an application from source to the environment that is running in to be able to identify what that problem is. The other thing that we make it simpler to do is also providing this delivery bill of materials. You probably are familiar with this concept of software bill of materials that is used in the supply chain mechanisms to identify what are the composition of a component. Here, what we are adding to that composition is also the signatures of when this artifact is created, a signature of when it is deployed, signatures of when that is approved. Those are important for the delivery within an organization because you not only want to know what your binary contains, but also what are the commits that went into the binary compared to the previous one. What are the differences in the security posture for each of these components that are including compared to the previous one? And who is the approver for this? What are the policies that have been checked for this one to go to the next stage in the deployment? So all of that is captured in the delivery bill of materials. So here, if you have any of these policies like, is the artifact built in an approved environment? Has the artifact been modified after it is built? Is this artifact tested in a environment that has the performance test in it? So all of this gets logged and tracked and gets signed. And at the time of deployment, we verify it, all of these checks and say the policies required for the enterprise are all been passed, right? So that makes it very simple for compliance time. If you want to generate a compliance audit, you can simply take the delivery time checks, we call that delivery firewall or deploy shield at the delivery firewall, and provide that as an evidence. So here is the way that because the delivery bill of materials includes software bill of materials, we can present that. If you are sharing your images with the third party and they want to see what the composition of your system is, it's fairly easy to share that. The advantage here, again, by collecting this delivery bill of materials is the ability to do smart diff. So there is a discussion in the industry. Okay, now we have say software bill of materials. What do we do with it? How do we use them? So this is the answer to that, right? So you have a software bill of materials, and the versions change on a continuous basis. You may have multiple deployments in a day, or maybe one deployment a day. What are the changes that are going in? Because in the deployments, typically when they have vulnerabilities, uh, you take exceptions to those. As you build a new system and are releasing it, is the exception also applied to the new one? Or any new vulnerabilities created in that you need to focus on? It makes it fairly easy to make those kind of decisions and approve it. The last but not least is the ability for you to generate these policies and share with the entire group. Typically, the security teams are small, but they are the ones that kind of approve the policies that needs to be applied to different types of applications. So this makes it fairly easy for security team to define these policies. We have pre-built policies, hundreds of them. That are also tagged with different types. And so, for example, NIST, CISA, or mid-tray attack kind of frameworks. Uh, they can package them and apply to specific applications. Makes it fairly easy to share that type of things, and they can manage it centrally. Right, and with those, we also have the ability to customize these policies. So we have this integration with ChatGPT. There are two things that we do here. One is you can specify in English saying, this is the policy that I want, and it generates the Rego code that you can use to automate your policy. Right? The second thing that we help here is this. If you have a vulnerability that has come up, like here, then you can ask ChatGPT to say, how do I fix this vulnerability? So we already preceded with some prompts. So you get a response in terms of whether based on the code, if it's a Java or a Python, or what third-party library versions that you should upgrade to resolve this vulnerability. And the last but not least, of course, is the ability to search for the systems that are currently affected. Let's say you found a new vulnerability, CVE 2023-20863. You want to know if any of your systems are affected today with that vulnerability that are running in your production environments. You can simply search, you get the response, because we have the context of this application end to end. Makes it very easy for you to do that. So that's kind of what we wanted to present today. What we went through is the supply chain attacks are increasing. Because of that, you have to secure your delivery process, the delivery systems, and the delivery process. So we looked at some of the gaps in open source Spinnaker and the kind of things that we have done to our customers to fix those issues and provide you a secure Spinnaker, and also the extensions to the Spinnaker that allows the delivery process to deliver securely, including the policy management, secrets management, and providing this application context end-to-end for security teams to interact with the development teams and operation teams. So this is something that we have been fairly successful in implementing at our customers. If there is more you would like to know on what we are doing with our secure software delivery, it also works with Argo CD. So you can reach out to us and we can help you take the next steps on it.
All right, thank you, Gopi. So please enter any questions in the chat. We had one question, Gopi. It's pretty interesting. I mean, we've talked about like the raising threat levels, and let's say there's enterprise company that has a Spinnaker installation. Let's say they wanted to increase their security and compliance posture. They needed to because of this current environment. how do they get there? What are the most common implementation challenges by organizations, and how can they be effectively addressed? Is it uh, lack of expertise, or is it integration? Maybe you can provide from your experience, what you see.
Right. I mean, most organizations use the open source software, right? This is from the Spinnaker. So as we have seen, there are some gaps in the open source Spinnaker for you to achieve full uh, compliant deployment. So those are the things that we help with, both in terms of updating the components to the latest versions with no vulnerabilities, uh, or setting up this configuration in a way for the secrets management that makes it uh, a fairly reliable, secure system to use to deploy. And the third one is this ability to integrate with the policy manager and managing these policies. So these are the three typical areas where they fall short and we kind of help them with.
Great. And by the way, you mentioned some compliance frameworks like NIST. If you go to the next slide, just for our viewers, we've developed a NIST white paper. And so you can go ahead and download that off our site. A couple other questions from the audience. Do you scan open source software to find known vulnerabilities and give suggestions to upgrade to version X? Is that an example?
Yes. So as you saw, there are multiple things that are going on. Right? In the delivery process, when a binary is created, you can generate the software composition from the binary, or after you push it to a repository, we can scan the binary to find what the vulnerabilities are. Typically, the National Vulnerability Database that we use includes the version that has a fix for it. In most cases, and there are some cases where the fix doesn't exist in the vulnerability database. So we depend on that NVD to provide that response. But we also support this ChatGPT interface, which can provide some guidance on how the rest of the industry is dealing with that specific vulnerability, either upgrading to a newer version or a code snippet that will work around that vulnerability. And so we have all of that integrated into the system that gives you the help you need to resolve that vulnerability.
Great. And you maybe sort of referred to binaries. The second question is, how do you create security posture for binaries that are included? I'm assuming included in the distribution.
So the binaries, so there are many types of binaries, right? Like the jar files and things like that, plus Docker containers. So the scanners that we use can scan these binaries. And if you have third-party binaries that are included in your distribution, what we have is something called a deployment firewall. The deployment firewall essentially is tracking what are the binaries that are being applied right now. And then for those binaries, what is the scan posture? And you can have policies on those. So the short answer is yes, we also scan all the binaries that are going to be deployed, whether they are built by your organization or not.
Great. Any other questions? By the way, so with this evolving sort of threat landscape, how often should organizations sort of reassess and update their security strategies? What's your recommendation on that? Is it continuous?
Yeah, it's a sort of a continuous process. There are two parts to it, right? So people started using cloud services more commonly now. And if you look at the cloud services, there are new services that are being introduced all the time. And the development groups are essentially adopting anything that they can find that simplifies their life, either open source software or cloud services. So the ability for us to discover that a new service is being used or a new software open source is being used by the developers uh, is critical. Once we discover, then that is the point at which we would then analyze the security requirement for its posture and specify what can be used, cannot be used. So typically what we have seen is the discovery process is hard, so which is what we are simplifying with this system. So once you identify there is a new service or a new uh, open source binary that is being used, software, then we would look for the known vulnerabilities in those environments and the best practices for those. And that's the point you would apply. But otherwise, it's a continuous process. Even for the ones that you're currently using, there may be new vulnerabilities that are discovered and published from the database. So what we do is we run periodic scans continuously on the things that you're running and report on anything new that we find.
Very good. And one final question. Great. Really appreciate the questions from the audience. Do you have an accurate picture of where the software is eventually deployed? Once a vulnerability is discovered and recommendation given to upgrade, can you guide an organization to pinpoint places where that software exists in the deployed base, mainly for SaaS or cloud deployments?
So that's kind of what we strive for with our integrations. So if, either with Spinnaker, Jenkins, Argo CD, we continuously monitor what is being deployed. We also look at the cloud resources directly to monitor what's currently running and see that mapping that to what's being deployed, what we know as an application context. If that doesn't match, then that would be a flag saying, hey, this is something that we don't know how it got there. So yeah,
Right.
that's one of the things that we do.
If there's a vulnerability in a binary in an artifact repository, right, and gets deployed out into your environment, and we get notified, we're able to provide a view into where that binary is deployed, right? Is that correct?
So we can provide the view of where that binary is deployed, but the context, if we have this context of Spinnaker, then we can synthesize the entire end-to-end data. So if someone has deploying out of band from the enterprise required policies, then we can flag that saying, hey, we cannot synthesize how it got there, but we see there is a new system that's running with the vulnerability. So that's the alert we can provide.
Great. Well, thank you so much for your time. Everybody, thank you so much for your time today. We really appreciate your attendance. I hope you got everything out of it. We'll send out the slides and the recording. And if you want to have further discussions with OpsMx experts, go to our website and we'll schedule a call with you and we'll discuss more about this very interesting and important topic. So Gopi, everybody, thank you very much and have a good day. Thank you.
Thank you, Mark. Thanks for everyone for joining us today.